Hello and welcome to another Redis Tech Talk. Today we're going to talk about the high availability features of Redis Enterprise. Redis open source is a great solution for caching, but as your business and your data grow, it can be difficult and expensive to find the staff to keep it highly available, scale it, and protect your data along the way. That's where Redis Enterprise can make your life easier and, yes, cheaper by automating many tasks your staff would otherwise have to do manually. In this video, we'll take a look at how to make Redis highly available. Part of that is making sure your data is replicated and distributed so that you don't lose data when something fails, and when things go down, having all your data is great, but it doesn't do you any good if there isn't a running copy of Redis to serve that data. Highly available systems guarantee a high level of uptime. They're designed to be fault tolerant, highly dependable, operate continuously without intervention, and don't have a single point of failure. What does this mean for Redis specifically? Well, it means that if your primary Redis server fails, a backup kicks in and your users see little to no disruption in the service. We need two things to make this happen: replication and automatic failover. Replication is the continuous copying of data from a primary database to a backup or replica database. But having a backup of our data is not enough for high availability. With automatic failover, we need a mechanism that automatically kicks in and redirects all requests towards the replica when the primary database becomes unavailable. In theory, machines and storage and networks just work. And certainly data centers and availability zones are reliable. In the real world, of course, those things fail now and then, and that's often completely out of our control. But our responsibility is to make sure that we never lose data and that our applications keep running no matter what goes wrong. That means we need a data layer that's highly available, which in turn means two things. First of all, we need to manage our precious data so that we never lose anything. Here at Redis, we're very proud to say that no one using our high availability features has ever lost data from a Redis database. The second thing is that we have to set up Redis itself so that the database stays up and running no matter how catastrophic a failure might be. Fortunately, Redis was built as a database as a service in the cloud, so it has features to handle failures. But let's start with the data. The basic technique we'll use is replication. That means we have our primary database and we also have one or more copies or replicas of that data. And all of those replicas are updated whenever the primary database changes. Even if those changes happen on the other side of the world, we have to keep everything in sync. That gives us at least two copies of our data. Redis uses a three-step process to create a replica. First of all, Redis creates a snapshot of the primary database. That's a compacted version of all the data in the database when the snapshot was taken. Next, the replica takes the snapshot and loads all the data from it. That means our replica exactly matches the primary database when it took the snapshot. But of course, our database didn't stop working when it took the snapshot. We've got a large dynamic business here, and our data is always being updated. So the third and final step is that the primary database starts sending data to the replica. The first thing it sends is all of the changes that happened since it took the snapshot. From that point forward, anytime there's a change to the primary database, it sends those changes to the replica. Now we've got our primary database and some replicas, and everything is being kept in sync. The primary database is the only place we can write data. The replicas are read-only. But what if we're doing lots of reads? If the primary database is the only place we can read data as well, that can become a bottleneck. To improve performance, we can read data from a replica as well. So if we have one primary database and two replicas, we now have 3 copies of Redis that can handle our read requests. This triples our throughput and is a great way to scale our applications. Replication is meant for high availability, of course, but it's also useful for load balancing and improving throughput for reads. So those are the basics of replication. Even better, with Redis Enterprise, setting up replication is as simple as checking a box in the console. And if we're replicating inside a cluster, more on clusters in a minute, Redis Enterprise makes sure that a replica is never on the same node as its primary database. As we move on to high availability, we should mention that Redis Enterprise is built on a shared nothing architecture, which means that every node has everything it needs to keep running. If, for example, the proxy that routes requests to the right shard was a single resource shared by every node in the cluster, that would give us a single point of failure, and that's the last thing we want in a highly available system. Now let's talk about how to deal with resources that fail or get disconnected. We'll look at a number of things that can go down, with each kind of failure more catastrophic as we go. To be clear though, when we talk about a Redis Enterprise node, we mean both the Redis Enterprise software and the host it's running on. That might be bare metal, a VM, a container, or a cloud instance. If any of those things go down, the node is gone. The first type of failure we'll look at is a shard that fails inside a Redis Enterprise node. A shard is simply an instance of the open source Redis we all know and love. A database can have more than one shard, and a replica of a database will have the same number of shards as the primary. Here's a short example. We've got a database that's stored in a single shard, and it has a single replica. As you'd expect, the primary and the replica are on different nodes in the cluster. And there are node watchdog processes in each node to make sure things are running properly. Now let's say a request comes in and the proxy sends it to the shard with the primary database. So life is great. But if the primary shard goes down, the replica becomes the primary shard and the proxy automatically sends all requests to the new primary shard. If the old primary shard comes back online, it becomes a replica. And finally, if the proxy fails, the Redis Enterprise cluster moves the database endpoint to the proxy in the other node. This is a great feature of Redis Enterprise. Our application doesn't have to know about any of this. Shards fail, proxies fail, nodes fail, the endpoint stays the same, and our app keeps working. The second type of failure happens at the Redis Enterprise cluster level. Our cluster has some nodes, one of which is the primary node in the cluster. The primary node makes decisions for the cluster if something goes wrong. And yes, if the cluster's primary node goes down, one of the other nodes becomes the primary. The replicas of the primary databases on the node that went down become primary databases, and life goes on. So that's what happens when a Redis Enterprise node inside a cluster goes down. Database replicas are promoted to primary databases, and we keep running. So what else can go wrong? Well, moving up the failure magnitude ladder, an availability zone or rack can go down. Obviously, we want to deploy our nodes across multiple racks and availability zones, but it can be complicated to set things up so that losing a zone or rack will always leave us with replicas of our data. Redis Enterprise has built-in logic to take advantage of different racks and zones. This is known as rack zone awareness. Shards are automatically dispersed across rack zones so that if a rack zone goes down, replica shards get promoted in other rack zones and the database stays online. Here's an example. We've got 4 primary databases and 4 replicas, and their shards are distributed across 3 different rack zones. Also notice that rack zone B contains the primary cluster manager in node 5. So let's say rack zone B goes down. We just lost nodes 4, 5, and 6, which includes the primary shard for database 2. Now the replica shard of database 2 in rack zone A becomes the new primary. We also lost the replicas for databases 3 and 4, so Redis Enterprise uses rack zone awareness to create new ones in rack zones A and C, and of course they're in different rack zones from the primaries. Finally, rack zone A contains both the primary and replica shards for database 2, so its replica is moved to rack zone C. When rack zone B went down, we also lost the node with our primary cluster manager. When this happens, a new cluster manager is elected to make sure cluster operations keep working. It's in node 9 in rack zone C. A rack or availability zone went down, but we didn't lose data, and our application is still running. The last disaster we'll talk about is a regional or data center failure. This is the biggest failure we can have. An entire data center or even an entire region of the globe goes down. Maybe there's a natural disaster, maybe there's a massive power failure. Somehow, lots of really bad things happened at the exact same time, and suddenly our application and its data have to adapt to a whole new world. Redis Enterprise lets us create geo-distributed databases. Those are databases with replicas that can literally be distributed around the world. When all regions and data centers are up and running, every user around the world gets great performance by using their closest replica. That's what we call local latency, and it's a huge benefit even if disaster never strikes. But if a region or data center does fail, our application can fall back to another replica somewhere else in the world, and we're still up and running. If the closest replica is far away, we may not get the best performance, but without that replica, we won't get anything at all. And when the lost region or data center comes back online, we can start using it again to get back to local latency for all of our users. There are 2 ways to create geo-distributed databases, and we call them active-passive and active-active. They're both extremely powerful and reliant, and which one you choose depends on your use case. Let's start by looking at active-passive. At a high level, active-passive replication has many read-only replicas around the world, but only one writable replica. As you would expect, changes to the primary database are sent to the replicas around the world. Changes to the replicas aren't allowed, so if something happens to the region or data center that contains the original primary, one of the replicas becomes the primary database. Now let's move on to active-active. What makes active-active special is that all of those replicas are writable, or to put it another way, anyone can change anything at any time. All of those changes are then replicated and reconciled. When that's done, all of the replicas are correct and all of the replicas are consistent. The technology that makes that happen is something called CRDTs. That stands for conflict-free replicated data types. We have a CRDT white paper and some other resources on our website if you'd like to learn more. For our purposes here, we'll simply say that CRDTs define very precise rules for how changes should be replicated and resolved. For our discussion here, We'll assume we have a database with replicas in San Francisco, London, and Sydney. With our replicas defined, any change, for example, made in San Francisco is automatically sent to London and Sydney. That's great, but what happens if something goes wrong? Let's say there's a network failure and the Sydney replica is completely unreachable. What Redis Enterprise will do is store all the changes made in San Francisco and London, and when Sydney comes back online, those changes will be sent to the Sydney replica and everything will be consistent again. Even better if this was just a network problem and the Sydney replica stayed up and running, any changes made to Sydney while it was offline will then be sent to San Francisco and London. Another great aspect of active-active geo-replication is that it delivers high availability. If you think of our replicas here, what we have are instantly accessible, constantly synchronized copies of your data. If any replica ever goes down, your application can immediately switch to another one and keep working. As a matter of fact, if you put your replicas in at least 2 data centers, Redis Enterprise guarantees 5 nines availability. So active-active geo-replication is a fantastic technology for building a modern data layer at global scale. Now for a quick astronomical example of how active-active geo-replication works. In our example, we have a database with replicas in San Francisco, London, and Sydney. Each browser window tracks how many times we click on each planet. With each click, the browser updates the local replica, and the changes are passed on to the other replicas. Off-screen, I'm connected to the Sydney replica on my iPad. As I tap the screen, the counter for Alderaan goes up in the Sydney replica as well as the 2 others. But what happens when the connections go down? I'll run a script that breaks the connections among all the replicas, then we'll see what happens. That will take a couple of seconds. Now when I click on the planets, the changes aren't replicated. Each individual replica responds to its local changes, but it doesn't know about the changes to the others. Before we reconnect everything, there is a hidden feature in this demo. If you click on Alderaan 42 times, it explodes. So I'll click on it in London until it's at 39, then I'll click twice in Sydney and once in San Francisco. When the network comes back online, all the changes will be reconciled, the counter will hit 42, and Alderaan will go out in a blaze of glory in all 3 replicas. I'll start the script to reconnect everything. That'll take a few seconds. In the meantime, we'll go back to our browser windows. And there we go. Once all the changes reach all the replicas, the universe's unluckiest planet is toast once again, and it's been annihilated everywhere. The other values are identical as well. All the changes in all the replicas were reconciled correctly and consistently. But you may have questions about how to get started. Does Redis Enterprise run on the public cloud I use? Can I get a license and run it on-prem? Can I get Redis Enterprise as a managed service? Or can I even run Redis Enterprise across multiple clouds with my data spread around the world? The answer, of course, is yes. Redis Enterprise gives you choice and flexibility. It can run in your environment today or in the cloud or both, and it's flexible enough to run in whatever your environment may be in the future. To sum it up, that can be any or all of on-prem, AWS, Azure, and Google Cloud, and it's available as a service, or you can license it and run it in whatever environment you choose. The active-passive and active-active replication technologies we just talked about make it easy to move data to or from or between or among different clouds and your data center. This lets you avoid vendor lock-in and unify your data as you migrate to the cloud. And of course, the apps that use that data can run on-prem and or in a cloud or multiple clouds. Now let's hear from Vijay Lakshmi Narayanan, Senior Engineering Manager at Freshworks. Freshworks is a SaaS company that provides a suite of tools for intelligent customer engagement. They have over 50,000 customers in over 120 countries, and they recently conducted an IPO with a valuation of over $10 billion. Vijay is going to walk us through their journey of moving from open source Redis to Redis Enterprise and why this was a cost-effective solution for their customers.
I'm Vijay Lakshmi Narayanan. I'm a Senior Engineering Manager at Freshworks. And today I'll be walking you through how Freshworks chose Redis Enterprise, how we moved from self-hosting Redis and open source Redis, and then we moved to Redis Enterprise. And most economical software for whatever price that you get, right? Now, unintuitive as this might sound, that does not automatically mean use free software, because free software is free only in the sense of beer, right? And when you want to run engineering, the costs that are associated with your software rise very quickly when you want to give your customers the main things that they need. And the things that customers most value, the non-functional requirements outside of their regular business use case, are that they want high uptime, they want availability, they as much as possible prefer fast results over slow results. So our Redis usage today is as described here in this slide by our Senior Director, Naren Janakiraman. You can scale open source, but it is not easy. The costs associated with hosting and your own open source systems, not just Redis, right? Even if it's MySQL or any open source software, these go up very high, very quickly. But that same measure can also help you as a guideline for, should I use open source or should I go with the enterprise version of any software? And the advantage for us that we get from Redis Enterprise is that the high availability guarantees of Redis Enterprise mean we can use Redis as our persistent database itself rather than just as a cache. And because of this, because we have Redis Enterprise, that means we have a persistent system, and there's only our only database is Redis Enterprise. We don't have to keep something like MySQL that stores policy information and use Redis for our caches and counting. Now, everyone knows that the reliability of your system is inversely proportional to the number of components you have. So the fewer the components you have, the higher your reliability. And highly available Redis has meant that we have one less architectural component, and that means we are that much just even monetarily we save money, and in terms of reliability we can sleep a little better, right? So this is kind of how we use Redis right now. The question in open source is not, in modern days, is not so much open source versus the commercial version, but it's rather how do you use both. So for us, our production environment uses Redis Enterprise, our sandbox uses Redis Enterprise, and our staging also uses Redis Enterprise. That's necessary because when we are doing benchmarkings, we need true validation. However, on our dev machines, we just run open source Redis, typically from Docker, and that just gets rid of a lot of our dev problems. But we know that the behavior is going to be the same both locally and at scale. And Redis Enterprise really saves us a lot in terms of DevOps headache.
Well, that wraps up our overview of the high availability features of Redis Enterprise. We've looked at how to keep our data safe, how to set up Redis Enterprise nodes so that our applications keep running as disasters strike, Finally, we heard from Vijay Lakshminarayanan of Freshworks, who told us how Redis Enterprise has helped them scale their business dramatically while keeping their costs in line and delivering the highly available system a thriving business needs. We hope you've enjoyed this session and keep an eye on our website for more Tech Talks. Thanks.